Bismillah ar-Rahman ar-Rahim. So let's continue chapter 10. We stopped here last time. I hope Adil is here to read it for us again.
Yes, I'm here, Doctor.
Yalla,
I'm just
Bismillah.
pulling up right. Okay. A uniform rod of length L and mass M is attached at one end to a frictionless pivot and is free to rotate about the pivot in the vertical plane as in the figure. The rod is released from rest in the horizontal position. What are the initial angular acceleration of the rod and the initial translational acceleration of S21?
طيب. Even we have this situation. We have this rod free to move. We release it from zero. So it will go into a circular motion. So he wants two things from us. He wants alpha and he wants A, the acceleration. So as I told you, the book will just go into derivation after derivation, and the book will end up with a certain equation which will apply only for this situation. Yani if I change the road, the whole derivation, we need to start all over again. So instead of that, I give you numbers and we start to solve the problem, hopefully to make things clearer. So let's assume إنه L is equal 1 meter, the length is 1 meter, and the mass is 2 kilogram. Let's find alpha. Well, first of all, we know that we can calculate torque by definition F R sine theta. I'm not talking about L because we are going to consider the center of mass. We are going to consider the center of mass, and the gravitational force will work as if the whole object is just a center of mass, a dot, and accordingly we will apply the force. So what is F? Well, F is mg. We have R, the center of mass, the distance between the pivot and the center of mass, and we have sine theta. If you look, sine theta is nothing but 1, because the force of the gravitation accelerate the direction of the force of the gravity is perpendicular to the motion at the beginning. So that means mgr. What is mgr? We put the values. It's 2 multiplied by 9.8 multiplied by half. That is 9.8 Newton meter. Yes, that's what I'm talking about. Gravity, when gravity acts on an object, it will act on the center of mass. It will act on the center of mass, not in the whole mass. So we consider the distance between the center of mass. So here is center of mass. So this distance is L over 2. And we call it R, our R. Of course, it's uniform mass, we take half the length. تفضل يا عادل. عادل
We chose theta to be 90 degrees.
At the beginning, yes. At the beginning, the force is perpendicular.
Yeah.
The gravitational force is perpendicular. So it will give me a torque which is Fr sine 90, يعني Fr.
And what if the pivot like has moved to another location, another place? So how do we calculate that? Like how do we, let's say, specify the angle?
Well, based on the problem. Based on the problem.
Do we just like just like how we have done in the inclined plane?
No, it's
We
it's
assume here
well,
the center of mass.
no. The angle is, as we mentioned in the first part. So here, the angle, it's the torque. It's a cross product. So it's the angle between R and F. However, we didn't cover that in details لأنه that will be covered in chapter 11 and we don't have time to do chapter 11. So the angle is the angle between F and R. R is a vector and F is a vector.
And in the previous example, F was downwards and the angle was the 90 degrees between
Exactly.
R and D force.
Exactly.
And it's up to me to call it phi or theta.
Yeah, whatever.
Okay.
Right. So let's go back. So we determine the torque. Of course, it will be different because the torque is Fr sine theta, and theta is the angle between the force and the vector R, the arm of our torque. طيب, he wants alpha. Well, we know that torque is equal moment of inertia multiplied by the angular acceleration. يعني alpha, which we are interested in, is equal torque divided by the moment of inertia. What is the moment of inertia for the road? This kind of road, moment of inertia will be 1 over 3 m r squared. And if we change the road to another shape, I will change. I is always given unless I give you everything else and I ask you to calculate I. So I here is 1 over 3 mass. So in our situation mass is 2, and in our situation R here R here is, it's confused. Let's just change it to L. Now here there is a difference. The center of mass, look at the body, the gravitational force, look at the body as a center of mass. However, when we calculate the moment of inertia, we need to consider the total length. We need to consider the total length. So it is half 2 and the total length is 1 square. What's this value?
Doctor, can you repeat the what's M capital and why did you put half third?
That's the moment of inertia from the book. From the table of moment of inertia of different objects. It is 1 over 3.
So inertia is always mass times L squared over 3? Or what?
It depends on the shape of the object.
Oh, so there is a table for each shape. Yes.
That's
I remember
correct.
that.
Yeah.
Hmm.
Where is the table? Let me get, that's not the table. Where is it? We passed it.
I think it's down. It's at the bottom.
Yeah, this one. So each object has its own moment of inertia. So in our situation, it's 1 over 3 ml square. So it is 2 over 3 kilogram meter square. So we put it here, torque is 9.8 divided by 2 over 3. It will give me alpha. And if you use your calculator, it will give you 14.7 radian over second square. Yeah, moment of inertia will be given for you unless I give you everything else and I ask you for the value of moment of inertia. طيب, what is the acceleration? Well, we know that acceleration is equal alpha r, and in our situation r is L because we are asking for what is the acceleration at the edge, so it will be 1, and then it's 14.7 multiplied by 1, which is 14.7 meter per second square. لأنه moment of inertia has nothing to do with the center of mass. Moment of inertia is related to the shape of the object, not the center of mass. طبعا here is the book. He gave you this equation for this specific object. You cannot remember this equation, and it will take you too long to derive it in the exam. Plus, if I change the object of the shape of the object, this does not work. This does not work. So I don't know why he insists of doing that. طيب, let's have another example. تفضل يا عادل. نعم, اسأل.
Yeah, I just wanted to ask, why did we like choose the length divided by 2 when we use the
لأنه gravitation will act normally, all the physics will act on an object as a center of mass.
and the mass that was given in the question was the mass of the pivot.
لا, البيفت اللي هو المحور اللي بيتحرك عليه. الماس هي ماس الرود نفسه.
Okay.
هاي هي البيفت. هاي شايف اللي هو المحور. اما الماس هي الماس تبع الرود كله.
Okay, doctor, and if this is the case, Yaman has just asked a question that if the starting angle was 30 degrees, like
Yeah.
if the angle between the rod and the ceiling was 30 degrees, I don't get how we solve the question.
Well, then if I will write it in green so you are not confused. Suppose that we start like this. Yeah. So this is R and this is mg, and this is our theta. So when I write the first equation, torque will be F R sine theta. Theta is given, suppose it's 60, it's 45 or whatever. So I write F mg, R is L over 2, and then I write sine theta. And I find I find the value. I will have some mathematical value. And then I continue as usual.
Doctor, I mean the angle, not this angle, like on right on the pivot.
What?
Like if we draw a horizontal line above this rod,
This one?
yeah, here, and
No,
this was
by,
bigger
by
than
definition, this is 30 يعني.
yeah, this was 30.
طيب هاي بتصير 60. What's the big deal?
Okay, okay.
Yeah, what's the big deal? بصير هذه 30. هاي always this is theta. Always we have sine theta. No big deal. طيب, let's move to the next question. Read it for us.
Okay. Is my voice clear?
Yes, it is.
Okay. A wheel of radius r, mass m, and moment of inertia is mounted on a frictionless horizontal axle as in the figure. A light cord wrapped around the wheel supports an object with mass m. When the wheel is released, the object accelerates downward. The cord unwraps of the wheel, and the wheel rotates with an angular acceleration. Find the expression for the angular acceleration of the wheel, the translational acceleration of the object, and the tension on the cord.
طيب, he needs three things: translational acceleration, angular acceleration, and he wants the tension. He wants the tension. Again, as I told you, he will start with those equations and then finally reach an equation. You cannot memorize the three equations, and if you are going to derive it in the exam, it will take too long, and it depends on the shape of the object, because if I change the shape of the object, the whole thing will change. So let's solve it and try to put numbers to make it a little bit clearer. طيب, what are the values for this? Suppose that M is equal 3 kilogram, R is 30 centimeter, the small mass for the object, small mass is equal 1 kilogram, and for this object, for this shape, moment of inertia is equal half m r square. So I is equal half capital M r square. يعني right away I is equal half multiplied by 3 multiplied by 30 centimeter square, which is equal 0.135 kilogram meter square. طيب, how to solve this equation? Let's write our equations. Our sheet, let's write the equation that we can write for the small object, this one. We have mg minus t is equal ma, and here the small m, not the large m. And also we have the torque is equal I alpha. But what is the torque? The torque is F R sine theta, and in this situation always theta is 90. I will not bring the table, I will just give you the moment of inertia equation for the problem. And that is equal I alpha. Well, لاحظوا, notice that F here is our tension, not torque, tension. معناته this equation, tension multiplied by R is equal I alpha. So our physical two equations, I have equation 1 and this is equation 2. Now I want to solve this, solve my question using these two equations. Any way you like to solve it, solve it. However, in my situation, I will use the following. I will use the following. So we have torque, I know R, 0.3. I know alpha, it's 0.135. I, it's 0.135. And I know that A is equal R alpha. I know R is equal 0.3. And then I multiply it by alpha. Because I am interested in alpha. So basically, from this equation, I have torque is equal 0.45 alpha. Alpha is the angular momentum, angular acceleration. Angular acceleration. So I know that from this equation, I know that tension is 0.45 alpha. So I go back to equation 1 and write mg minus 0.45 alpha is equal ma. And alpha is R, alpha in terms of A, so I can solve it. A is equal alpha. No, I need to find alpha. Sorry, I need to find alpha. I put the numbers, so the mass is 3 kilogram by 9.8 minus 0.45 alpha is equal the small m, and here the small m, so this is 1 kilogram. Is equal 1 kilogram A. And what is A? It is R alpha. So this will be 9.8 minus 0.45 alpha, and it is equal to 0.3 alpha because R is 0.3. Sine theta, we said in sine theta, theta is 90 in this problem. Theta is 90 in this problem. So sine 90 is 1. Why I substituted wrong? Where did I put it wrong? That is correct. TR is equal I alpha. Nothing wrong here. why I took tension, not mg. We'll revise the previous problems. Revise يعني when you have an object like this, for example, here is M2 and here is M1. How I write this equation? Do I write it M1G is equal TA? No, I write mg minus t is equal ma. So how do you want me to write the equation يعني? طيب, so let's come back here. Yeah, brother. يعني I have to write everything as if you have no experience يعني. T multiplied by R is equal I alpha. So what's this? So T 0.135 divided by 0.3 alpha اللي هي هاي. طيب, I continue. I have this equation. I continue solving. So it will be 0.9. Here we miss R. We have R alpha. So it is 1 kilogram and R is 0.3, and then I have alpha. So it is 0.3 alpha زائد 0.45 alpha is equal 9.8. يعني 0.75 alpha is equal 9.8. يعني alpha is equal 9.8 over 0.75. So what's alpha? Somebody calculate it for us. كيف 13.1 و 12.8؟ 9.8 divided by 0.75, so it's 13.1 radian per second square. So that's the first part. That's the first part. So let me revise it. mg minus t is equal to ma, and m here, the small, is the mass of the small object. Also, I have the equation torque is equal I alpha. Torque is the tension multiplied by the radius, and theta is 90, is equal I alpha. So tension multiplied by the radius is equal I alpha. I calculated I, it was 0.135. R is 0.3, so I have a new equation. Tension is equal to 0.45 alpha. I use this equation here. So this is tension. Tension is equal to 0.45 alpha. So mg minus 0.45 alpha is equal to ma. And then the mass is 1 kilogram g 0.45, and then I have 1 multiplied by the acceleration. The acceleration is equal r alpha, because I'm interested in alpha. So it is 0.3 alpha, and then I calculate my alpha. The second part, he asked us to calculate the translational acceleration at the edge. So here at the edge. That is easy, because we know that A translational is nothing but R alpha. R is 30 centimeter, or multiply by 13.1, and that will give me the value 3.92 meter per second square. اتفضل يا عادل.
Just for a quick one question, like I know this, but R here is what does it represent? The radius of the wheel?
R represents the radius of the wheel.
Okay.
Doctor, actually, you have another question as well.
اتفضل.
The A tangential is equal to the acceleration, the radial acceleration times the distance, or the radius?
لا angular acceleration, لأنه الراديال acceleration هي التانجنت acceleration.
يعني احنا حسبناها في نمبر 2 دي ايه بالظبط؟
هذه اللي هي translational acceleration.
والترانسليشن دي اتجاهها فين بالظبط؟
باتجاه الحركة لتحت.
لتحت، اوكي. واللي احنا جبناه من شويه في الستبس الطويله الاولانيه
angular
دي
acceleration.
كانت
angular acceleration.
اوكي تسلم.
صحيح. طيب the last part he asked us for the tension. What is the tension? Well, from this equation we know this equation. إنه tension multiplied by R is equal I alpha. معناته tension is equal I alpha divided by R, which is I is 0.135 and alpha is 13.1. R is 0.3, so it will give me the translational acceleration at the edge, divided by 0.3, and that is 5.9 meter per second square. That's Newton, sorry, Newton. So those equations, if I change the shape of the object, will be useless. طيب الآن we come to the concept change in the opposite direction. يعني الجسم is going up instead of going down. But how the system will go up instead of going down? يعني how this system will go up instead of going down.
Maybe, Doctor, if it wasn't like frictionless and the wheel was rotating to the right side, so it would go up.
Yeah, but you know my way of teaching the course. يعني I don't want to go in deeper difficulty. يعني you have difficulty to understand the concepts just mentioned in the chapter. يعني why
Okay,
you
well,
want to go.
yeah,
يعني my way of teaching the
yeah.
course, the time is so limited, so I don't want to make it harder than what is in the book.
Okay, I got it.
لأنه in the question the object start from rest. The object start from rest. So
Yeah,
no way on earth that it will move up. It has to move down.
yeah. Now
Unless
I
there
can.
are other torque source, if it is like a motor or there is another mass on the other side or whatever, but that's not the scope of the problem. يعني already it is difficult enough for you in this situation. So we won't go into deeper details. Understand this and جزاك الله خير يعني.
Okay, we will try to do so.
طيب الحين احنا اخذنا كل شيء equivalent in linear motion, اخذنا what is equivalent in angular motion. So in linear equation we know that the kinetic energy is half mv square. Half mv square. طيب what is equivalent in the rotational kinetic energy? Well, equivalent to that is half I omega square. Half I omega square. And that we call this as the rotational kinetic energy. Omega is the angular velocity. Omega is the angular velocity. We talked about it last lecture. Yes, we can apply energy laws, and I will give you two examples here. Not this one. This I will not do. But we will take two examples to illustrate this. الحين power. So this is the kinetic rotational energy. طيب, we covered power in linear motion. We covered power in the linear motion. طيب, what is power in the torque in the angular motion? Well, let me recall. Power in the linear motion was Fv, the force multiplied by the speed of the linear motion. The force multiplied by the speed of the linear motion. طيب, I know that torque is equal F R sine theta. طيب لاحظوا, let's assume إنه theta is equal 90 degrees. What will happen? Well, then torque is equal Fr. طيب, when the angle between the force and the object is 90 degrees, what is the work done by the force on that object? So what is work? How did we define work? It's F dot D, and that is F D cosine theta. So when the angle between the force and R is 90 degrees, that means there is no work done by the force on the object. لأنه now we are talking about cosine theta and cosine 90 is 0. فبالتالي بصير when the angle is 90 degrees بصير في عندنا full torque on the object, and that force will not do any work on the object, will not do any work on the object. So now we come back, force is equal F V, and we define the torque here as force multiplied by R. طيب, what is force alone? It is torque divided by R. So this torque divided by R. And V is the linear or translational speed. What is equivalent to that? It is the angular speed. And what is V in terms of the angular speed? It is omega R. So we end up that power, when you have a force applying torque on an object, power is nothing but the torque multiplied by omega. So now we have the equivalent of linear power, اللي هي كانت إذا بتتذكروا زمان here also can be defined as work divided by the time. That is when we have linear motion. But if we have angular motion, بصير الforce acting on the object power will be torque multiplied by the angular speed. I hope these questions are given in the formula sheets. أي question? Equations, عفوا equations. Yeah, PV power P is equal FV, it will be given. Power T omega will be given for you. But not those. Not those. يعني such equations will not be given for you لأنه as I told you, this is a derivation based on this object only. So you need to work it out using the basic physics, the basics equations, equation 1 and equation 2. So be careful. إيش يعني why? Why is common sense. يعني every problem you can derive its own equations for it. And if I derive the equation for you, what are you going to take the mark for? To substitute يعني? يعني if I derive the equation here and I give you A is like this and I ask you just to substitute يعني put the numbers and then you will take 8 marks. Those derivative equations you have to figure it out in each problem by using the basic physics. You write the basic equations and then you solve your problem. طيب إذا عندنا ال equivalent of power وعندنا ال equivalent of kinetic energy. And if you remember, we said work is equal the change in kinetic energy from previous chapters. يعني kinetic energy 2 minus kinetic energy 1. And the same concept will apply. اللي هو work is equal the change in kinetic energy, but we add rotational يعني kinetic energy rotational 2 minus kinetic energy rotational 1. This is 2, not square, 2. We have the same concept, And this slide will just tell you both relation or both equivalent between rotational and translational motion. This table I'll bring in the exam, sure, no problem, sure, but not the special derivative equation for each shape of the object. But this I'll bring in the exam, no problem. طيب هلا we will do the same example that we just started with, but now we are going to use the concept of energy to solve it. The concept of energy to solve it. Read it for us, يا عادل.
Okay. A uniform rod of length L and mass M is free to rotate in a frictionless pin passing through one end. The rod is released from rest in the horizontal position. A. What is its angular speed when the rod reached its lowest position?
طيب إذا الآن he asked us for the angular speed, and we are going to use the concept of energy to solve this problem. To solve this problem. And again, this equation is directly related to the shape of this object. لأن هون this I he substitute as 1/3 ml square, and this is the shape of the rod only. If I change the shape of the rod, this equation will change and this equation will change. طيب, so in order to hopefully make it clearer, so let's assume that the mass for the object is equal 2 kilogram. Let's assume L to be 1 meter, and of course I is equal 1/3 mass L square, and right away we can calculate it. It's 1/3 multiplied by 2 multiplied by 1 square, which is 0.67 kilogram meter square. So this is I right away I calculated. طيب, let's apply the concept of conservation of energy. Conservation of mechanical energy. So that means the change in kinetic energy plus the change in potential energy must equal to 0. So let's do it step by step. So what's the change in kinetic energy? It is K2 minus K1. طيب, what is K2? يعني what is the rotational kinetic energy when it reach this position? يعني all potential energy is يعني تحولت, all the potential energy is transferred into kinetic energy. All the potential energy is transferred to kinetic energy, rotational kinetic energy. So then it will be half I omega square. And I can put here final, and I will remove it in a second. Why I will remove it? Because I don't need to write it. Minus, what is the initial kinetic energy when the pivot is not moving? We will just release it. So it's a 0. It's a 0. So in order to remove confusion, I'll just use, what's this? I will just use this because now I know that initial omega is equal to 0. Why it's 0? Because at the beginning of, it's like kinetic energy. When you have an object at the beginning of the motion, the object is stationary. That means the kinetic energy is equal to 0. So at the beginning of the motion, the object is stationary, so kinetic energy is equal to 0. طيب, let's have a look at the potential energy. I'll change the color. It is U2 minus U1. So what is the potential energy when the object reach this position? This position. يعني center of mass is here. يعني كان الأوبجكت L over 2 وبعدين صار على مستوى center of mass. It is a 0. Why mg L over 2? This is my reference point. This is my reference point. Potential energy is always relative. So it's a 0. طيب, what's the initial potential energy? The initial potential energy, well, we have a minus sign, m, g, h. What is h? h is equal L over 2. معناته انه ال change in potential energy is equal minus mg L over 2. طيب, let's write this equation now. This equation states that half I omega square minus mg L over 2 must equal to 0. معناته I end up half I omega square is equal mg L over 2. Yusuf Ali, final potential. We have a ball here. This is my final potential. And this is H. Here the potential mgh. Here the potential is 0. It's relative. The potential energy is always relative. طيب, can I solve this equation and find the angular velocity? Of course, just I put the numbers. So first of all, half will go with half. So omega square is equal mg L over I. يعني omega is equal mgl over I. Put the numbers to 9.8. L is half divided by I. We said L is 1 meter, so it's a half. Divided by I. What is I? 0.67. And what's this value? Use your calculator, Sheikh. 3.82 radian per second. الحين لاحظوا في حسنة واحدة عملها الكتاب في الديريفيشن. لاحظوا هاي المسألة، انتبهوا عليها يا جماعة. هلا احنا وصلنا هون اوميجا سكوير is equal mgl over I. طيب what is I? Let's write I in terms of its components. It's 1 over 3 m l square. Look what happened. It's here 3g over L. That is omega square. عارفين شو معنى هالكلام؟ Do you know what's the meaning of this? إنه in this problem I can ask you to find omega square without giving you the mass of the roll. You can calculate omega square
12 o'clock p.m.
or omega or alpha without knowing the mass of the object. Although the shape of the object will change I, however, mass will just disappear. This is equivalent to the concept in the linear conservation of energy, mechanical energy. When I start, for example, this is a ball, and this is a 0, this is H, and I ask you what is the speed of the ball just before it hits the ground. So we say half mv square is equal mgh, and m will disappear. So the final speed, and we did that so many times, it does not depend on the mass. And exactly the concept repeated itself here, that I can calculate the final omega without knowing the mass. So in the exam, when you are missing the mass, still you can solve your problem. Yani I saw it before, the student is sitting and thinking and said, Ustad, how I can solve the problem, I don't know the mass. How I will solve the problem, I don't know the mass. أو student ثاني بيحكي أستاذ السؤال فيه غلط. There is a mistake in the question. I cannot solve it without the mass. لا, you can solve it without the mass because it's a concept that in such a situation, angular velocity, acceleration does not depend on the mass. Exactly like what happened here when mechanical energy is conserved and all the potential energy is converted into mechanical energy, mass will disappear. And بصير final velocity does not depend on the mass. Small light objects and heavy objects will have the same final speed. So pay attention to this. طيب determine the tangential speed. هذه سهلة. AB. Well, V is equal R omega, and R in this situation is L over 2 omega, and that is equal half 3.82. That is equal to, what's half of that? 1.91 meter per second square. So again, I can calculate V and omega without knowing, or without the need of knowing the mass of the object. طيب هلا بسألنا سؤال تريكي ممكن تقرأ لنا التريك يا عادل؟
Okay. What if we want to find the angular speed of the rod when the angle it makes with the horizontal is 45 degrees, because this angle is half of the 90, for which we solved the problem in the previous slide? Is the angular speed at this configuration half the previous answer, that is 1/2 the square root of 3g over L?
Then what he is trying to say, he said we calculated the translational speed and the angular speed at the bottom, here at the bottom. Now he say what will be omega in the middle of the way? What will be omega in the middle of the way? Is it half of what we get? And the answer is wrong. The answer is wrong. And I will give you an example in linear motion, so you are convinced. هلا احنا we said انه half mv square is equal mgh. So يعني v تساوي 2gh under square root. So suppose that we have an object that is 1 meter far from Earth. So what will be the speed of the object at the bottom when it reaches 0? Well, it is 2 multiply 9.8 and multiply by h, which is 1, under square root. So what's that speed? It is 4.34 meter per second. طيب. What will be the speed at half the distance? Is it half the speed? طبعا الأنسر no. The answer no. لأنه see what will happen. So this is V to 9.8, and then I have a half, and then everything is under square root, and this will give you 3.1 meter per second. So at h over 2, v h over 2 is about 70% of VH. Yeah, you get the concept. So the concept of that, when we are at the middle angle, 45-degree angle, the angular speed is not half. Is not half. It's like the linear speed. So let's do it for half the angle. تفضل يا عادل.
Doctor, is it related to design? Like 45 is almost 0.7, and that's 70%. So Are these things related to each other?
It is related to the angle but not the sine, the cosine.
Ah,
ليش؟ لأنه if you want to calculate h and you know L over 2, because h is the height, what's remaining of
yeah.
the kinetic energy, yes, h will be L over 2 cosine 45. Because we are interested in this height, and this is L over 2, so this value h is equal L over 2 cosine 45.
And here comes the 70% difference.
It will be, we will see that it is like 85%. I will mention the calculation now. I will write the calculation details. So when we have rotational at 45, h is equal L over 2 cosine 45, which is 0.35 meter. So that's what's remaining of the potential energy. That's what's remaining of the potential energy. It's not the sine, it's cosine. So we have half I omega square is equal mgh. So we just put the numbers 0.67 omega square is equal 0.35 meter multiplied by the mass, which is 2, and multiplied by g, which is 9.8. So omega square is equal 20.58. That is at 45 degree. يعني omega at 45 degree will be equal 4.54 meter radian per second, which is not half. Let me record the number that we got. It's 3.82 and we have 4.54. It's not half at all. It should be lower. You are right. It should be lower. That means we did a mistake here. In the calculation. I will revise it after the recording and change it, inshallah. But you are right, should be less. It should be less. But I will revise it, inshallah, after the class. طيب. Now the last example here, or the example before the last, we saw this, the Atwood machine. We call it Atwood machine. In this Atwood machine, we have mass 2 and we have mass 1. Previously, ya jama'a, ya shabab, how we solved this kind of problem previously? We said, okay, massless pulley. Remember? Massless pulley. And we have M2. We have M1. And we said, yeah, let's write the two equations. We said M2, suppose it's going down and this is going up. We said M2G minus T is equal M2A. And the second equation, T minus M1G is equal M1A. Remember that? The old nice days? Those were very nice days. And then we add the two equations, so T will go with T, and we end up with M2G minus M1G is equal M2A plus M1A. And we solve it. It's very easy. The reason you cannot, when you consider the pulley, you cannot use this anymore. وانتبهوا إذا جاء هذا السؤال في الامتحان وكتبت هدول المعادلتين هتاخد 0. Why? لأنه now in this situation when there is I have T2 and I have T1 and T2 does not equal to T1. So I cannot write the two equations. I cannot write the two old equations to solve this kind of problem. I have to use different technique اللي هو conservation of energy. طيب هلا شوفوا يا جماعة. The pulley has a mass, it has a moment of inertia, etc. هلا خلص عنا الوقت. أنا حقوم بتسجيل بقية الشابتر. في عنا مسألة هذه اللي هي الأتود ماشين، وفي عنا كمان مسألة اللي هو when we have an incline, when we have a sphere going into an incline plane. هدول المسألتين حسجلهم وحط لكم إياهم على البلاك بورد. والأسبوع الجاي إن شاء الله مش هناخد ماتيريال جديدة، هناخد مراجعة. فإذا عندكم أي سؤال في هاي الماتيريال شوفوا الفيديو، وإذا عندكم أي سؤال بشرح لكم إياه. لكن الآن خلص علينا الوقت، وهيك بكون يعني الماتيريال لغاية.
ممكن احنا ما ناخدش الماتيريال اللي باقي علينا، ما ناخدوش كله مثلا، بدل ما احنا نتفرج على ريكوردينجز وكل دكتور يروح مدينا ريكوردينج نتفرج عليها، يعني ضغطه فوق ضغطه وفي الاخر مش هنجيب الدرجه اللي متوقعينها.
لا هذا شوف احكي لك، هذا ما له علاقه، لانه الكونسبت احنا اخذناه. انا بدي اعطيكم تو ماثيماتيكال اكزامبلز. الكونسبت خلص اخذناه وانتهى، لانه الكونسبت تبع هاي المساله، شوف الكونسبت تبع هاي المساله اللي هو الاتود ماشين بيعتمد على الكونزرفيشن اوف ميكانيكال انرجي، وهذا غطيناه. والكونسبت تبع هاي المساله برضه conservation of mechanical energy when you have rotational energy، وهذا غطيناه في الليكتشر. فأنا هعطيك حسجل لك two mathematical examples لصالحك، عرفت؟ يعني ما حضيف عليك ماتيريال. الكونسبت غطيناه اللي هو conservation of rotational kinetic energy with conservation of translational kinetic energy. فهو لصالحك، مش إضافة مادة جديدة عليك. واضح؟
اوكي يا دكتور، يعني الاسبوع الجاي ان شاء الله بناخد شابتر 11.
لا الأسبوع الجاي خلاص مراجعة، آخر أسبوع دراسة الأسبوع الجاي.
يعني مش هناخد أي ماتيريال جديدة
مش خلص انتهى، وقفنا يعني. هذا هو.
الحمد لله. أنا بحسب هتسجل لنا
لا
ناخد شابتر كمان.
لا أنا حسجل two
كويس.
mathematical examples to illustrate to help you understand the concept that we already explained، اللي هو conservation of mechanical energy. زمان كنا نحكي kinetic energy و potential energy، الحين نحكي kinetic energy، kinetic translational energy and potential energy. عرفت كيف؟
حلو جدا.
فهذا غطيناه اوريدي، هذا غطيناه في الشابتر، بس حسجل لكم مثالين حسابيين. هلا شابتر 11 ما كفى الوقت، فبالتالي ما تعملوا الواجب تبع شابتر 11، يعني حشيله من العلامه.
حلو. طب انا عندي سؤال وطلب صغير جدا واكيد سهل يعني.
تفضل.
دلوقتي امتحاننا ان شاء الله 2/5.
ممتاز.
وانا مثلا عندي النهارده فاينل وعندي فاينلز وبروجكتس كتيره، فالويكند ده ضروري جدا استغله في البروجكتس وكده. فلو تقدر تاخر واجب الشابتر ده مثلا الاسبوع الجاي، والله هيكون فعلا يساعد جدا، يعني هيساعدنا جدا جدا، خصوصا ان احنا الاسبوع الجاي مراجعه وهنفهم الشابتر ده اكتر مع شويه حلول وكده، وان شاء الله يعني نجيب درجه كويسه ومش هيأثر معاكم في حاجه. يعني كده الامتحان الفاينل متاخر الحمد لله.
يعني ما بعرف في هاي، يعني I don't promise anything. انت اشتغل على انه الهوم ورك due to its time، لأنه التغيير الواجب ل 11 مجموعة مشكلة، يعني تغيير الوقت ل 11 مجموعة مشكلة.
ما حصلت قبل كده يا دكتور؟
ما هي حصلت وحصلت مشكلة طويلة، لأنه يعني تغيير التاريخ الامتحان، التاريخ التسليم الواجب ل 11 مجموعة بدها تاخذ من الدكتور اللي بغير، بدها تاخذها 3-4 ساعات، وسبيشلي في هذا الوقت لأنه الجميع مضغوط بما فيهم الدكاترة. تمام، بدها تاخذ من الكوردينيتور، بدها تاخذ 3-4 ساعات بس عشان يغير التاريخ، لأنه he has to do it group by group.
اوكي. طب دكتور، هو كل الهوم وركس متاخده في الدرجات ولا مثلا بتشيلوا اوحش اتنين ولا ايه؟
بنشوف هذا اللي في نهاية الكورس، يعني لما نشوف علاماتكم وأدائكم الرائع إن شاء الله.
علاماتنا وحشه يا دكتور.
لا إن شاء الله بتتحسن، لا إن شاء الله بتتحسن،
ان شاء الله.
لا إن شاء الله بتتحسن. أنا إن شاء الله
إن شاء
في
الله.
الويك إند هذه حراجع أوراق الامتحانات تبعتكم كلها. تمام. لأنه
والبونسز بقى يا دكتور ايه؟
البونص
إيه؟
كل امتحان فيه بونص إن شاء الله، كل امتحان فيه بونص بإذن الله.
ان شاء الله ان شاء الله.
فمثلا مثلا نشوف ان شاء الله تكون اخبار ساره، لانه حراجع كل الطلاب اللي اجوا في الامتحان، اللي اجوا في المراجعه وقالوا له دكتور راجع لي ورقتي هون وراجع لي ورقتي هون، كله حراجعه وان شاء الله بترتفع العلامه. يعني انا
ان شاء
من
الله.
اللمحه الاولى بظلكم تسألوا، من اللمحة الأولى أعتقد أنه أكثر من واحد حيجيب علامة كاملة في الامتحان. من اللمحة الأولى للمراجعة أعتقد أنه أكثر من واحد حيجيب علامة كاملة.
يا ريت يا دكتور والله، ان شاء الله ان شاء الله حتكون كده.
أي نعم. خليني أفتح الكل حضور.
الدكتور